Hey, how's it going, do-it yourselfers? Today we're going to go over how a MAF or mass airflow sensor works. But not just that, we'll also cover how a MAP or a manifold absolute pressure sensor works. And then we'll go over how you can test these two sensors using nothing but a basic multimeter. Alright, first up, the mass airflow sensor. Alright, so your mass airflow sensor is usually going to be located right after your air filter box and this air hose that goes from your air filter box to your engine, as is the case on this Audi, or as is the case on this 2003 Ford F-150. It's actually located right on your air filter housing. Now the job of your mass airflow sensor is to measure the mass of air that's entering your engine. And then it provides this information to your car's ECU. Your car's computer uses this information to time your fuel injectors and adjust your air-fuel mixture. And the way that this is done on this hot wire mass airflow sensor is through that element, or in other words, the hot wire that's in that plastic housing, which you guys might just be able to make out. On these sensors, your car's computer is supplying this hot wire with constant voltage and also constant ground. As air flows through this sensor or through the housing, it cools down the hot wire. As a result, the resistance of this hot wire changes, resulting in a different voltage drop across this sensor. That voltage drop is transferred back to your car's computer through this signal wire, and that's how your car's computer knows exactly what's the mass of air entering your engine. So typically the connector that goes to this mass airflow sensors is going to be either a 3, 4, or a 5-pin connector, as is the case on this sensor. If it's a 3-pin connector, we already know what those 3 pins are for. If it's a 4-pin connector, that's usually just an extra ground for the casing to clean up the signal that's going back to your car's computer. And if it's a 5-pin connector, you usually won't have a sensor case ground. Instead, you have the 2 extra wires are going to be for your inlet air temperature sensor, which are housed with your mass airflow sensor into this housing. You're going to have one constant voltage, usually 5 volts for that sensor, and then the return signal line to your car's ECU. So again, on this 5-pin connector, right there on the side is the element for our inlet air temperature sensor. Alright, next up, manifold absolute pressure sensors. Your manifold absolute pressure sensors are usually connected to your intake manifold by a vacuum line, as is the case here, or they're directly bolted into your intake manifold. Now the job of your manifold absolute pressure sensor is to measure the amount of vacuum you have inside your intake manifold, and also boost or pressure if you have a turbocharged or a supercharged engine. Alright, so these sensors basically have a diaphragm inside of them, and that diaphragm is moved up and down based on how much vacuum or boost there is inside your intake manifold. And again, similar to our mass airflow sensor, we're going to have 3 wires. One of them is going to be our constant voltage, another one ground, third one signal. As this diaphragm moves up and down, it changes the resistance of this sensor. That change in resistance translates into a varying voltage, which is supplied through this signal wire back to your ECU. Alright, now as far as how you can test these sensors, we'll start with the MAP sensor. But first things first, you want to make absolutely sure that there's no cuts in this vacuum line connecting your MAP sensor to your intake manifold. Next, you want to get in your car, put the key in the ignition, and put it in the on position without turning the engine on. Next, you grab your multimeter, turn it on, and you want to choose 20 volts on the DC voltage scale. Next, you'll ground your black test lead, then remove the connector that's going to your MAP sensor, and then simply start probing these pins, and the one that gives you any voltage, that's going to be your constant. In our case, it's going to be this first one that gives us 5 volts. So we're going to put down this red one as our constant voltage supply wire. Next, we grab our multimeter again, and this time we're going to change the settings to continuity. And then we're going to probe the 2 remaining pins, and the one that gives us continuity to ground is going to be our ground wire, or ground pin. So here we go. This third one is going to be our ground. So there, this red one is going to be our constant voltage. This third one is going to be our ground. So the remaining wire has to be our signal wire. Next, you want to grab 2 paper clips, and you want to back probe your signal and ground wires. Just make sure you get a good back probe in, and that they don't touch each other or short to ground somehow by touching the firewall and whatnot. So next, you want to connect them to your test leads. Once again, grab your multimeter, put it to the 20 volt setting on the DC voltage side, and turn it on. Next, get in your car and turn on the engine. Alright, so as you can see at idle, we got about 1.6 volts. Now, this is going to vary from vehicle to vehicle, but actually, if I'm not mistaken, this is supposed to be closer to 1 volt. And then as you open up the throttle and the vacuum goes down, this voltage should rise. Alright, so as you saw, the voltage didn't increase as we opened the throttle, so we could have a potential problem with our MAF sensor here. Now there is something that can make this go up though. Alright, so as you saw, we were able to make this voltage go higher when we opened the throttle plate quickly and closed it. I think that's basically going to indicate a problem with our MAF sensor. So when you're opening a throttle plate slowly, as the vacuum decreases, it's not returning to its position, I'm assuming, as quickly or as it should. But when you do it quickly, there's a sudden drop of pressure or vacuum, then it can move back. There's more force, it can move back a little bit quicker. Or I guess we could have a tiny crack in this vacuum line that's coming from our intake manifold. Alright, let's see if we can find a vacuum leak. Alright, so no vacuum leaks in that line, so that makes it very likely that we have a bad MAF sensor here. Alright, I'm going to call it a bad MAF sensor here, especially since I just remembered something. Remember when we were testing the pre-cat O2 sensor in my previous videos and it was showing very lean? Now, when you think about it, when this MAF sensor is stuck at 1.5 or 1.6 at idle, and when you open the throttle plate, letting a lot of air in, that voltage is not going up, telling the car's computer that there's more air coming in. The car's computer is just going to assume that there's very little air coming in, so it's not going to open the fuel injectors much. Therefore, you're going to have very little fuel, all the while the throttle plate is actually open and there's a lot of air going in. So it's going to cause a lean condition. Now I could be wrong on this, but that's my call as of right now. Bad MAF sensor on this, causing a very lean condition on this car. Now before you replace your MAF sensor though, it's very important that you bench test it using a vacuum pump. But we'll save that for a separate video since this video is getting too long. Now as far as how you test the mass airflow sensor, well basically the same principles. You get your multimeter, you put it to the ground test lead to the battery ground, then you check for voltage first. You should have 12 volts for your MAF sensor, and if you have one of those with the inlet air temperature sensor, you'll probably have 5 volts for that, so you can separate that. And then you switch it around and find your ground, and then the remaining two are going to be, if you have a 5-pin, the remaining two, one of them is going to be for the temperature sensor, the other one's going to be for your the mass airflow sensor. Or you can always look up a wiring diagram if you have your car's repair manual and find which wires are which. Now if you want to see me actually test the mass airflow sensor using a multimeter, I'm going to edit in cuts from a video I did about 1.5 years ago on how I tested the mass airflow sensor with a multimeter right now. Alright, so as you can see, we got 4 pins on this wiring harness. Alright, so the first thing we want to do is to find our constant voltage supply from our ECU. So we're going to get our multimeter, turn it on, and then turn our settings to 20 volts since we don't expect to see anything more than 12 volts when testing for voltage. Next we'll ground our black test lead. Next we'll get in our car, put the key in the ignition, and turn the ignition to the on position without turning on the engine. Alright, next we'll grab our other test lead and we're going to touch each pin, and the one that gives us 5 or 12 volts we're going to write down as our constant voltage supply wire. Alright, here we go. We'll start with bottom left. We got nothing. Top left, nothing. Top right, and here we go. We got 12.6 volts, and there we found our voltage supply wire. Alright, so next we're going to try to find our constant ground wire, and we do that by getting our multimeter and putting our settings to ohms and measuring resistance from each pin to ground. And I'm going to choose this last setting on this multimeter, which will not only give us a reading but also give us an alarm or a beep whenever we have ground. Alright, so while checking for ground, you want to make sure you exclude the last pin, which was our voltage supply wire, because you don't want to check the resistance of a hot wire. Okay, so we're just going to start from the right bottom pin and work our way around. And there we go, first try, we got it. So our right bottom pin is going to be our constant ground wire. So basically now we're just going to reattach our connector and then back probe the 2 remaining wires. And it's not going to matter exactly which wire is which of the remaining 2, because once we hook up our multimeter to that, if we have them the wrong way around, we're only going to see a negative on the side of this. But in order to get a more accurate reading, if we do get a negative sign next to our voltage reading, all we have to do is just switch the test leads around. And paper clips are great for back probing these connectors. Just make sure you get them in all the way and you press them in all the way and you make good contact. And next we'll use these alligator clips to attach our test leads to the back of our connector. Since we're going to be measuring voltage, we go back to our multimeter and put our settings back over to 20 volts. Alright, so what we're going to do next is to get in a car, start the engine, and then measure our voltage at idle. At idle, this car should have about 1 volt. Okay, before I start the engine, I think I need to mention that the readings I mentioned, the 1 volt at idle for this car, which is a 2001 F-150 with a 4.2 liter, is at idle when the engine is properly warmed up. Now I'm going to be doing this on a cold start, so the RPM is going to be a little bit higher, therefore our reading is going to be higher than 1 volt. But then if it's a good MAF sensor, it's going to come down, decrease gradually, and then settle around 1 volt. There we go, problem solved. Alright, so it's been a couple of minutes and it's settled around 0.85 to 0.9 volts, which is about right. But now I'm just gonna play with the throttle plate. I'm gonna slowly open it, and we should see a gradual increase in the amount of voltage being put out by our MAF sensor. And then once on the way down, we should see a gradual decrease. So that's it. Remember folks, if you have automotive questions, you have 36 hours after every new video I post to my channel. So this service actually is only provided to subscribers. So if you're not a subscriber and watching this, make sure you subscribe, wait for my next video when it pops up into your subscription feed. Click on it, post your question. It doesn't have to be related to the whatever video I'm putting up that day, and I'll hopefully get to answer your question. And if you don't have any questions, don't forget to check out these other related videos, of which I'll put links on the site and also in the description box. Alright, thanks for watching. I'll see you guys next time.